Good morning all. Today I fancy taking something apart, so how about this? It's an electric toothbrush. So this toothbrush has been very kindly supplied by EC Technology, and they've very kindly said that I can take it to bits. So let's quickly unbox, and inside we have instruction manual, thank you card, and toothbrush. Let's see if it works. Oh wow, that's really quiet. Oh, what's it doing? Actually, if I put it on that card, you might be able to hear it. So that's off. Is this the battery level? That's on. And then it goes into a sort of wobbly thing, which is that's off. That's standard. And that's wobbly. You can see the little wobbly symbol there. So it looks like it's got a sort of standard oscillation of this. This is oscillating at, what would we say that frequency is? A couple of kilohertz, something like that. And then if you go into this mode, it's obviously modulating that with some sort of modulation signal to put a bit of variation into the head movement, I guess. Now there's also this plus and minus button, so let's switch it on and get it making a sound. And there isn't a lot of difference, but it sounds a bit like it's being pulse width modulated for lower power. Let me put that actually on the phone, maybe that will be easier to hear. So that's maximum, and then those are the other two. Maximum, medium, minimum. So yeah, I think what it's doing is it's pulse width modulating the power to the motor to vary the sort of intensity of drive. There are some symbols here. It says sonic motor as opposed to ultrasonic, I suppose. Supports wireless charging, so that'll be the in the base of the toothbrush there'll be a loop of wire for inductive charging. IPX7 waterproof, of course, and a 3D brush. So let's see what else we've got in here. Charger, toothbrush heads, and also something in here. I've got a feeling this is the travel case. Yeah, portable travel box. Right, in here we've got a portable travel case. Now one thing you notice about this is it's not designed to take the mains charger, and I think the reasoning behind that is that this, if you look at the base, says voltage 3.7 volts. So we assume from that that this has a lithium battery rather than a nickel metal hydride, and therefore this will last, I think it says up to 30 days. Now not many people have holidays in excess of 30 days, so you just take the toothbrush and the tooth heads and you don't bother taking the charger with you. So have a quick look at these brush heads, because there are two green ones supplied and two blue ones supplied, and I remember reading that one has firm bristles and the other one has soft. The green one seems to be soft, the blue one seems to be a bit firmer, so you can choose which one you like. Well, let's plug this onto the toothbrush and see what the movement is. So it looks to me like the toothbrush head itself is just a solid piece. There are no moving parts in here, and you can see that there is allowable movement there. So I think the shaft just oscillates backwards and forwards, and it doesn't seem to oscillate much, because if I switch it on, the logo doesn't seem to be doing a lot of movement, but you can see that there's some resonance on some of the bristles there. And if I put it into the wobbly mode, we're getting a little bit more resonance there. So yeah, this is just oscillating backwards and forwards at this frequency. Maybe I can try and work out what this frequency is. So in terms of the electronics, there's actually quite a lot going on here, because you've got generation of this frequency, whatever that might be. You've got the wobble mode, so it's introducing some sort of modulation into that frequency, and you can hear that if I hold the motor, that frequency doesn't change. So it's not being generated mechanically, it's being generated electronically. 3 levels of pulse width modulation, that's also being done by the microcontroller, reading the switches, of course, and oscillating the motor. So yeah, there's quite a lot that the microcontroller in here is actually doing. Right, so I think it's time to start taking this apart. I think we're going to have to start spudging. That looks the most promising. Taking that gold cap off the top. Yeah, that came off quite nicely. Where's that gone? Right, that wasn't really holding anything. That looks like it's just a bit of trim. So I think I'm going to have to go in here next. Now I think, unfortunately, this toothbrush is not going to survive my attempts to take it apart. In fact, putting the spudger under here means really ripping this apart. This top bit seems to be plastic, so I think I'm going to peel that away. I might try and force it up. Oh, that switched it on. Yes, but I need to get in there somehow. This bottom piece is also seems to be able to be moved a little bit, so I might be able to remove the bottom insert as well. Right, that seems to be coming off in one piece now. We've got a date in there, 17/6/20 something, so 2017 is my guess. But this plastic cap and the gold piece just seems to be like trim. And I think this is, I don't know, I thought it might be a metal tube, but I don't know, maybe it's plastic. Okay, so I'm going to start working on this bottom section now. So I didn't really want to pull the base section out in case the wires connecting to the inductive coil broke, but there seems to be some sort of O-ring here. So what I'm just doing is working this, taking this plastic off and just seeing what I can see before I pull that out. Right, look what I've discovered up inside here. It's a little sticker, and there's actually a screw in there, but it's one of those annoying triangular ones. So I think I've got a security screwdriver set somewhere. Oh, that's annoying. I've got tri-wing, these 3-pointed screwdriver bits, but I don't actually have a triangular bit. Okay, yes, the tri-wing screwdriver actually worked. The screw obviously wasn't very tight. Now we can see the coil of wire there. There's a bit of enamelled copper wire there. And I can also see 2 clips, which are sort of one-way clips. So if I push them in, I should be able to take the whole inside section out, and we can take a look at it. Right, so I've broken away the plastic that's holding that in, and there it comes. Now, oh well, the electronics is very accessible, so that's nice. Where's the battery? Oh, the motor's there. That's clipped on, so that might unclip. Might be able to take this apart the remainder of the way in a little bit more of a civilized fashion. Right, well, it looks like you can switch the unit on with the up and down, plus and minus buttons, and actually set the level even before the motor comes on. You can't switch it between standard oscillation and wobbly oscillation. You have to do that with the on-off switch, but that turns it on. Then you've got the 3 different intensity levels, and then the wobbly oscillation mode you press by pressing the power switch essentially twice. Now this chip here actually has some markings on it, so I'm quite intrigued to see what that is. Right, this chip says on bright on it, and it's got an enormously long number, sort of OB39308A something or other, if that is indeed the number. But yes, that's an on bright chip. What's this one up here? That's a CST118S. Now my guess, looking at the M1 and M2 connections and the bits of wire that go off to the motor, is that that's some sort of motor controller chip, but we can look that up. And of course the on-bright is almost certainly a microcontroller, but I've never heard of on-bright before. The lithium cell is underneath this cover here. Now that looks like an AA-sized lithium, which I believe is 14500 or something like that. Unfortunately, the markings on it are just out of sight, but it probably says what type it is and what model it is, but whether or not that'll come out, because I don't know whether this is a tab welded one or maybe whether it's just a standard button top and flat bottom. Maybe that will actually pull out. Let me give it a gentle bit of encouragement. I can remove this rubber thing here, which is covering the LEDs, which just provide pathways for the LED light for the various LED configurations. But I've got a funny feeling that this battery is got tabs welded onto it, because I've tried to lift it out and it doesn't seem to want to come. I think they might be soldered onto the board, this placed through the board and then soldered onto the board after the battery is placed in, so I'm not sure I'm going to be able to get that out. There is a little clip there which will enable me to lift the top of the PCB away, but then I've got the motor wires. They're quite long actually. I'll see if the PCB will come away, but I'm pretty sure the battery is fed through and then soldered, so the only way that's going to come off is if I unsolder it. Right, let's take this top off. There's a really long O-ring here. It's really deep, so the likelihood of any water getting in there is pretty minimal, I would say. Let's see if I can coax this housing off the top here. Yeah, there it is. And that's the motor. Now, I don't think this is a conventional motor. I think this is, I suppose I should turn it off really. I think this is really almost like a speaker. It's just got coils and it's setting up an oscillation, but the frequency of oscillation is determined by the chip, and the motor driver, well, not the motor driver, that's just driving it, but the frequency determined by the chip. And this is, yeah, just like a voice coil really. Right, so I've got the motor out. One of these enamel copper wires is slightly longer than the other, so it's tilted over at an angle. But you can hear there the frequency quite clearly. And if I go into the oscillation mode, then it's definitely being modulated. Quite heavily, it would seem, because that's really bouncing around on the mat. Whereas that is quite a nice continuous tone. But I think I'm going to have to unsolder these wires to get the motor out and put it on the outside so that we can see where the wires go in. So while the soldering iron warms up, I can't find much on this CST118, but I found this on eamtau.com. It's definitely a motor drive chip, CST118S, motor drive SOP8, but there's very little information on it other than it's just a motor drive chip. And as for this OnBright chip, this is onbright.com, on-bright.com, and down here it seems that the OB39 chips, the one in the toothbrush is an OB39S, but there are some OB39Rs, are low pin count package MCU products. So these are just microcontrollers, is my guess. Well, I say it's just a microcontroller. I mean, you can't really say a microcontroller is just a microcontroller. But anyway, there it is. That's the OnBright. So let's turn that on. So the motor's out, and I can see, well, the coils of wire, but also some screws there. So I think it'd be worth taking that motor apart. I think that'll be the end of hearing that sort of 2 kilohertz whine, if that is indeed the frequency. But yeah, let's take this motor apart. A couple of screws at the back there, and a couple of screws at the front there. Now, presumably have some sort of bearing for the shaft to rotate inside, I would hope. Is this gonna come apart? Not easily. Oh, maybe. Perhaps a bit of coaxing with my screwdriver. Oh, actually, it looks like a bit of enamel copper wire runs from one side to the other, so that will probably break if I continue to force that open. But that has come open. Okay. Right, well, this is interesting. There's a shaft and a bearing at this end, and we've got an armature of sorts with neodymium magnets embedded in it by the look of it. But at the other end there's just a spring. This is obviously spring steel and this thing just rotates by a very small amount against that spring which is embedded in the plastic there. There are two coils, one wound on this side, and then there's a link piece that runs across there, and the one wound on the other side. So if I reassemble that then and push that down on that sprung sort of it's like a shark's fin shape almost, isn't it? Then that motor should continue to operate. So I thought it'd be quite fun to take this apart while it's actually running. Let's see if I can. No, can't get it in there. Oh, there's something loose in there now. Not sure what that is. See if I can force this apart without breaking that link wire. And it's still kind of working. I wonder if that would change the impedance of whatever that chip's driving, whether it's not going to be happy like that. But yeah, that's still oscillating, even sort of with only 1/2 on there, not as powerfully. And I can feel that that's moving slightly. Let's try the vibrating mode. The vibrating mode has a much wider swing. I can feel that. So I don't quite know what the modulation is, but it's more aggressive, certainly. And this even works with only 1/2 of the case shell on it. Probably not as well. Let's try lifting that out. Of course, it's not going to work if I take that out, is it? It's got to be under the influence of the magnets and whatnot. But yeah, that's the motor. Right, that thing that was rattling is a spring, and that was pushed down into a little circular hole in there. So there's a spring obviously pushing this motor forwards. I don't know why. Why would there be a spring pushing this motor that way? I don't know. That's a bit odd. And if I hold the motor on the mat so that it resonates, you can quite clearly hear the effect of the 3 power levels. So I don't know whether that is some sort of pulse modulation, pulse width modulation, or whether it is genuinely increasing the power to the motor. I can't really tell now that it's out of the toothbrush. And really the only other piece of circuitry that's of interest really is the charging end. So I've just plugged this into the mains, and if I poke that in the hole, we can see that red light comes on. Oh, and that's obviously modulating. It's not flickering to my eye, but it's flickering as far as the camera's concerned. Oh, that seems to be pulsating in brightness. Yeah, that is pulsating in brightness to my eye. Interesting, when I take that out, it turns the circuitry on, not in motor running mode, but just briefly turns all the LEDs on. There are 2 LEDs there, so my guess is that the red one goes off and a green one comes on possibly when the thing is fully charged. But yeah, that's where it's drawing its inductive from the main side. Not sure what voltage is across there. I suppose we could have a look at that actually. Whoops. Oh, well, it's quite hard to do. I was trying to put my probes. There are 2 coils down in this coil, it seems, and 2 sets of pads here, but I'm not reading any AC volts on either the lower set. It's quite difficult to keep them on there. Just about 0.03 volts, or the upper set. And it's just occurred to me that I wonder whether these aren't at 50 Hertz. I wonder whether they're at some sort of high frequency, because interestingly the base is actually multi-voltage. It says it's 100 to 240 volts, 1 watt. So the question is this putting a 50 Hertz oscillation or magnetic field through this coil, or is it doing it at a higher frequency that this meter is just not ready to read? I've got no DVMs with frequency on, unfortunately. That's a bit of an oversight, isn't it? Not quite sure why they feel it necessary to have 2 coils in this section down here, so I thought I might just peel away that for the moment. Yeah, there are definitely two different coloured wires in there. Yeah, two different coloured enamel copper wires. There's a red one and a sort of coppery coloured one. You can see there are two sets of wires running up to these points, A1, A2, A1, A2 dash, possibly. Yeah, this is interesting. Why are there two sets? There's two diodes there, so I should actually be able to measure a DC voltage on the positive of one of those diodes and the negative of the other, I'd have thought, shouldn't I? Yes, I can. So we're measuring 4.13 volts there coming out of one of those diodes, and 4 volts, of course, is ideal for charging a 3.7 volt lithium battery. And it was a little bit brutal, but I've worked out that the battery is a CR14500. So what's that? 18650 is 18 diameter. This is 14 diameter, 50 millimeters long, 800 milliamp hours, 3.7 volts, and it's SUNES. So yes, that was a complete, and you might say a rather brutal dismantling of this EC Technology toothbrush, not a torch, it's a toothbrush, with an inductive charging coil there, lithium cell, circuit board with a microcontroller and a motor driver, and of course the motor, which is more of almost a speaker really than it hasn't got a commutator. It's not a conventional motor, but yeah, interesting to see what's inside a state-of-the-art toothbrush. But I don't think there's much chance of getting this thing back together. Cheerio.